Hey everyone, welcome to another week of MathCat. This week we're going to be talking about addition, multiplication, and division properties and rules. First, let's start with addition properties, and we're going to be talking about the commutative property, which we touched on in a previous video, but we're going to talk about it more extensively in this video. The commutative property means the order numbers are added does not matter. So if you had 3 plus 5, that's the same as 5 plus 3. If you had 4 plus 2, that's the same as 2 plus 4. So you can switch the ordering of the numbers being added and you still get the same answer. The next addition property is the associative property. So the associative property states that the grouping of numbers added does not change their sum. So if you did 2 plus 3 plus 4 and you grouped the 2 plus 3, so you did that first. Remember, order of operations says you do what's in parentheses first. So this would be 5 plus 4 equals 9. Well, you could also group the 3 and the 4 where you add them first. So you would get 7 and you'd add 2 and you'd also get 9. So no matter how you change the grouping of numbers being added, you still get the same answer. The third property for addition is the identity property. This states that adding 0 doesn't change the value of the sum. So if you had 2 plus 0, that still equals 2. If you had 9 plus 0 or 0 plus 9, that still equals 9. You can add 0 to any number and you still get the same number back. Now let's look at some multiplication properties. So just like addition, multiplication also has the commutative property. The commutative property for multiplication states that the order of the numbers being multiplied does not change the product. Remember, the product is what you call the value you get when you multiply two numbers. So just like in addition, where we could swap the order and get the same thing, that's the same property for multiplication as well. So if you had 3 times 5, that's the same as 5 times 3. And if you had 4 times 2, that's the same value as 2 times 4. So switching the order does nothing to the value. And now, in the second property we have for multiplication is the associative property. The grouping of numbers being multiplied does not change the product. So if you had 2 times 3 times 4, if I grouped the 2 and 3, so I multiply them first, I get 6 times 4 equals 24. But if I grouped the 3 and the 4 instead, I multiply that first and I get 12, and I get 2 times 12 is also 24. So just like with addition, with multiplication, grouping the numbers being multiplied doesn't change the product. The third property is the identity property. Multiplying by 1 does not change the product. So with addition, if you add 0, you don't change the sum. But with multiplication, it's multiplying by 1 does not change the product. So you could do 6 times 1, and that's still going to give you the same value, 6. 1 times 2, you're still going to get 2. So you can multiply any number by 1, and you're still going to get the same number back. The fourth property of multiplication is multiplying any number by 0 is always going to equal 0. So 0 times 6, you're going to get 0. 4 times 0, you're going to get 0. 0 always, you can see it kind of like 0 cancels out any number. 0 destroys any number. Anytime you multiply by 0, you're just going to get 0. Now let's look at some division properties. The division rule for 1 states that dividing by 1 will not change the quotient. Remember, the quotient is what you call the result of dividing two numbers. So if I had 8 divided by 1, I'm still going to get 8. If I had 2 divided by 1, I'm still going to get 2. This only works when the 1 is in the denominator. So like 3 divided by 1, I get 3. But 1/3 is not equal to 3. So it doesn't work for having 1 in the numerator. That only works if you put 1 in the denominator, if you are dividing a number by 1. Let's look at another division rule, the division rule for 0. 0 divided by any number gives 0. So if I had 0 divided by 5, I get 0. If I had 0 divided by 1, I get 0. If I had 0 divided by 2, I get 0. But keep in mind, this only works for when 0's in the numerator. So this is not true to say 2 divided by 0, that does not equal 0. Saying 2 divided by 0 equals 0 is not true. So that only works when you have 0 in the numerator. Let's look at an example problem. MathCat shares her quarters. MathCat gave 1 quarter to each of her friends. If she gave away 6 quarters, how many friends does MathCat have? So this is, in a previous video, we talked about equal groups, division problems, and that's exactly what this is. So we're giving away the same number per group. So in this case, 1. So we have 6 total, and we're going to divide that in groups of 1. So you're basically asking how many groups are there of size 1. Based on the division rule for 1, we know that dividing by 1 will not change the value. So 6 divided by 1 is also just going to be 6. So 6 divided by 1 equals 6. So this problem is an example of the division rule for 1. Let's look at another problem. MathCat has 4 empty bowls. She put 0 fish crackers in each bowl. How many fish crackers are in the bowls? This is kind of a weird one. It's just an example of the 0 property for multiplication, but it's kind of strange because there's no crackers. Like, who, it's not really a real life example, but it illustrates the 0 property for multiplication. So if you have 0 fish crackers times 4 bowls, the total fish crackers in the bowls are 0. So this just illustrates that anything times 0 is just 0. Let's look at another example. The commutative property of addition. MathCat has 4 crayons in her pencil pouch and 6 crayons on her desk. How many crayons does she have in all? So we have 4 crayons in her pencil pouch plus 6 on her desk. Now, what if MathCat counted the 6 desk crayons first and then the 4 pouch crayons? Would that total change? Well, based on the commutative property of addition, we know that we can switch the order of the numbers being added, and that does not change the value. So these are equal. So we get 10. Let's look at this problem. MathCat is sorting stickers for her math notebook. She has 3 shiny star stickers, she has 2 rainbow stickers, and she has 5 heart stickers. How many stickers does she have in all? So this one shows the associative property of addition. And the reason is because to find all of the stickers, you have 3 of the stars plus 2 of the rainbows. You can add those 2 together first, and then you have 5 hearts. And the associative property says this is the same as if you grouped the 2 and the 5 together. Either way you do it, you're still going to get 10. It doesn't matter what order you add the numbers in or how you group them together. Let's look at this example. MathCat packs markers. Each art kit has 3 packs of markers. Each pack has 4 bundles of markers. Each bundle has 5 markers. How many markers does MathCat need for one art kit? So each art kit has 3 packs of markers, and in each pack is 4 bundles of markers, and each bundle has 5 markers. How many markers does MathCat need for one art kit? By the associative property of multiplication, we can group the numbers this way, and we get 12 times 5 equals 60. Or we can group the 4 and the 5 and multiply those first, and we get 3 times 20, which is also 60. So by the associative property of multiplication, it doesn't matter what order we do the multiplication or how we group the numbers together in multiplication. Let's look at a problem illustrating the commutative property of multiplication. MathCat is decorating her room with glow-in-the-dark stars. She puts 5 rows of stars on her wall. Each row has 2 stars. How many stars is that? So 5 rows, and each row has 2 stars. So we have 5 rows and 2 columns. So by our video on arrays, we know that is 5 times 2, which equals 10. So there's 10 stars. Then MathCat flips it in her mind. What if she thinks of it as 2 rows of 5 stars? Will she get the same total number of glow-in-the-dark stars? So she flips it around. So we have 2 rows and 5 columns. That's 2 times 5. And by the commutative property of multiplication, we know that that's the same. That equals 10. So you can flip the order of the multiplication. And still get the same value. Thanks for watching this video on math rules. Now you'll be able to identify these properties and use them to solve problems. Drop a like and subscribe if you enjoyed this video. See you next time.